Good morning, everybody. Today we're going to be working on properties of trig functions, primarily the period of trig functions to get into what that means, and then also determining the finding missing trig function values when you're given some information on other trig functions. So let's get started. When we're talking about trig functions, we notice that things start to repeat. So things start to happen periodically. So we call this moment or this length of values the period. Basically, how long does it take to start repeating the same values? For most of the functions, after you've gone 2 pi, things start to repeat itself because that's a full revolution. So you'll notice sine, cosine, cosecant, secant have a, if you add 2 pi or any amounts of 2 pi to theta, it becomes the same value as just sine of theta or cosine of theta. And again, that's just because 2 pi is going a full revolution. So if I'm trying to find sine of this value, well, sine of this angle and sine of this angle are the same thing because it's in the same spot. And the only difference between those two angles is 2 pi was added to the second angle. So they're going to wind up at the same place. The only trig functions that are different, the period of tan and cotangent, are pi. And that is because, say for tangent, this value and this value of tangent are the same thing because they're on the same line. So they have the same slope. Again, tangent's another way of describing slope. And this angle, so the difference between this and this, is pi. So if I add pi to this side, I get over here. And this works for any location of tangent. And cotangent is just the reciprocal of tangent. So its period is also pi. Get into if you're following along with the purple sheet, the fundamental identities, this is a 2-part lesson, so stay tuned for those portions. Primarily, you should just be adding the period identities of it. So if I add any amounts of 2 pi to the angle, it should be the same, except for tangent, and cotangent should be any amounts of pi. This k is a standard thing to add in there. K is just some integer, so I could take away 2 pi as well if it was a negative number, but any amounts of 2 pi should get you there. So because of that, to find the values of these without a calculator, you could draw the angle and figure out where it's at, or you can just take out full chunks of 2 pi. For part C, you're going to take out a full chunk of 1 pi. So let's I'm going to rewrite 17 pi over 4 as a mixed number. So 4 goes into 17 4 whole times, so this is the same thing as 4 pi, and then this would be 1 pi fourth left over. This is a whole amount of 2 pi. This is 2 sets of 2 pi, so if I plug this into sine, it doesn't do anything for us except for add extra work. Hence this problem. So this will have the same value as sine of 17 pi over 4. We know sine of pi over 4. We're well versed in this one so far. So this is root 2 over 2. Okay, same thing for this one. I'm going to take out full groups of 2 pi. I can take 2 pi out twice here. So cosine of 5 pi should have the same value of cosine of pi. Cosine of pi is -1. And cosine of 5 pi is also -1. With tangent, again, you can take out full groups of pi and it should be the same value. So 5 pi over 4, if I plug in, so 5 pi over 4 is 1 pi plus pi over 4. So this, if I plug that into tangent, doesn't do anything for us. Tan of pi over 4 will give us the same value as tan of 5 pi over 4. Tan of pi over 4, that would be root 2 over 2 over root 2 over 2. So this is when the slope is 1. So tan of 5 pi over 4 is 1. Okay. Here we're going to be given a couple clues, and we're just trying to figure out what quadrant this coordinate's in, or what quadrant theta is in, given the fact that sine and cosine have certain values. Over here it's cosecant and cosine. And think about these as x and y instead of sine and cosine. Sine is y, cosine is x if we're talking on the unit circle, but the portions should match. So this is saying that y is less than 0 and cosine is less than 0. The only place that this is true is in quadrant 3. If you remember, quadrant 1, quadrant 2, quadrant 3, quadrant 4. It goes counterclockwise to match trig, to match angles like that. So the big secret as to why we start in quadrant 1 and work counterclockwise has been revealed after this many years of plotting points. Over here, cosecant is greater than 0 and cosine is less than 0. Again, x is less than 0. 1 over y is greater than 0. 1 over y is greater than 0 when y is greater than 0. So when y is greater than 0, cosecant is greater than 0 in quadrant 1 and quadrant 2. Cosine, or x, is less than 0 in quadrant 2. So over here, answer is quadrant 2. We're going to get more complicated from here, just forcing us to find the rest of the trig functions, but finding the quadrant is super helpful because it narrows down the sign of each trig function. Should it be positive? Should it be positive? Should it be negative? And whenever I get problems like this, I revert back to the basics. When I give you a sine function, that's giving you opposite over adjacent, or sorry, opposite over hypotenuse. So I'm going to draw theta, and I'm just going to act as if it's a triangle, a right triangle. You'll see in this one, you could just use right triangle trig, and it would make sense completely, but others it might not, but you can still use this idea. So we're going to call this theta. Opposite is root 5. Hypotenuse is 5. Over here, check to make sure that the denominators are the same. If they're not, that means you'll have to do some extra work to figure out what the hypotenuse should be, what other values should be. In this case, they're the same, so you don't have to do much. It's just 2 root 5 over 5. Cosine is adjacent over hypotenuse, so we have that. So this is one version of the triangle you could be using. You could find all of the values from here, but you're going to find that you need to rationalize the denominator in some of these, primarily cosecant, basically all the ones that we haven't been given. So you might want to consider a different right triangle. And this right triangle is the same, it's similar to this triangle, but I'm going to divide everything by root 5. That way I don't have root 5 here. 5 divided by root 5 is root 5. So we can work with this, and it might make things easier. I think it does in this case. But you could get all of your answers from this, you could get all of your answers from this, or you could do a little combo platter between the two. It should give you the same values because theta is the same. We already have sine, cosine, so now we need cosecant, secant, tangent, cotangent. Cosecant, secant are these flipped, or you can go hypotenuse over opposite, hypotenuse over adjacent, and I think that might be easiest to work with this triangle, or again, just flip these. Cosecant is hypotenuse over opposite, or root 5 over 1, which is root 5. Secant is hypotenuse over adjacent, so root 5 over 2. If you went with these, you would just have to do a little extra work to divide out that root 5, but you should get the same answers. Tangent is opposite over adjacent, or 1 over 2. Cotangent is adjacent over opposite, or 2 over 1, which is 2. Okay, so those are the 4 remaining. It says to leave exact and simplified. This is exact and simplified. So if you're in My Open Math, don't type in root 5 as a decimal. Leave it as that. I'm sure you're starting to get the idea for that, or hopefully you are. All right, sine is 1/3. So again, opposite over hypotenuse, but it gives us this little hint here where cosine is negative. That means that we're working in quadrant 2. So we're working with this angle, theta. Now I'm still going to work with a right triangle because that's going to make things easiest. You can consider this on the unit circle, so the hypotenuse would be 1, sine would be 1, or y would be 1/3, or you could work with whole numbers if you wanted to. Both will get you the same answer. Again, nice thing with trig is it's flexible when it needs to be. So work with either one of these triangles. It'll get you to the correct answer. I would prefer to work with this. That way I'm not needing to square 1/3 and to find this to find this side. But I'm just going to use Pythagorean theorem. I'm going to call that length, or that leg, b. And then, so 9 minus 1, 8 is equal to b squared. Now b is equal to plus or minus square root of 8. The reason we have to consider the plus or minus is now we have to consider the sign of cosine. When we're dealing with real right triangles, you don't have to consider the plus or minus, but now we're not really working with a real right triangle, we're working with a coordinate, and we're using triangles to help us. In this case though, cosine is supposed to be negative, and this is going to relate to our cosine, so we want this to be negative root 8, or negative 2 root 2, depending on which version you're wanting to use. As far as I go, I don't care which one you use unless it simplifies more if you do take out perfect squares. Other than that, I wouldn't care. My Open Math might care. I have to check on that. But if that's the case, try both and just see if it works. All right, so we have 5 missing functions. We have cosine, secant, and forgot to mention this is going to be gross. Let's just work with this one. Sine, theta, tan, theta, cotan, theta. Sorry, we need cosecant. Cosecant theta. Cosecant theta is going to be hypotenuse over opposite, or 3. Cosine is negative root 8, or negative 2 root 2 over 3. Flipping the fraction, we get negative 3 over root 8, or if we rationalize, we're going to get negative 3 root 8 over 8. This does simplify a little bit, thinking about the 2 root 2, so I am going to take that out. 2 cancels with 8 a little bit. We get this as our completely simplified answer, so careful. I wouldn't be too nitpicky about this if it was on paper, but My Open Math might be. Tan of theta is going to be our slope, so 1 over negative root 8, so rationalizing we would get negative root 8 over 8. again, simplifies a little bit to this. I would then flip this fraction. We get negative 8 over root 8. And 8 divided by root 8 is negative root 8. Okay. Same idea here. This time we're just given tangent and sine. Tangent is positive. Positive 1/2 to be exact. So it's either going to be over here or over here. These are the two places where a slope would be positive going through 0, 0. So anytime it's positive, there are still two possibilities for tangent to be positive. And that's important because sine is negative. Sine is negative in 3 and 4. So the cross section between the two possibilities is quadrant 3. So we're going to be working with a triangle or an angle like this. I'm just going to zoom in on our fake triangle. Opposite is 1, adjacent is 2. This is our theta. Technically it's this over 180 degree angle, but we can use this for reference. Sine is negative though, so that means that our y value is negative and it's in quadrant 3, so our x value is also negative. So we're working with this, essentially. Hypotenuse is always going to be positive because it's the distance from, it's a distance. It's from the point to 0, 0. It also helps just keep everything else the correct sign. So hypotenuse should always be positive. Our height and our base of our triangle can be negative in these scenarios. 1 squared plus 2 squared is 5. Square root of that. So we're working with this set of numbers, and we're just going to use these for all of our trig functions. Sine, cosecant, cosine, secant. We already have tangent. If you feel like writing it in there, feel free. Sometimes I do. Alright, sine is opposite over adjacent. Just cutting to the chase, if you rationalize, you should get negative root 5 over 5, but negative 1 over root 5 would be the first step. Cosecant's flipping that, or hypotenuse over opposite. Root 5 over negative 1 is negative root 5. Cosine would be negative 2 over root 5, or if you rationalize, you're going to have negative 2 root 5 over 5. Flipping the fraction again, root 5 over negative 2, or negative root 5 over 2, either way. Cotan of theta is going to be tangent flipped, and in this case I would just go with that. So 2 over 1 is 2. And that's it. Again, make sure you're plugging away at My Open Math. This is a 2-day lesson, so making sure that you're not just turning it in once you're done with this portion, but once you spend two days of 30 minutes on this, you can click turn in and you count it good. But until next time.